This is section 4.5, more on curve sketching. Okay, so here are the problems. The highest we have to do is 45. And let me show you what's happening for this curve sketching section. On page 315, we're going to consider all of these. So the first ones are from pre-calculus, and then after that, calculus. So consider the domain of the function, intercepts, where does the graph touch the x and y axes, any symmetry, is it an even function, is it an odd function? Even functions have symmetry with respect to the y-axis. Odd functions have symmetry with respect to the origin, the one below. And on page 316, are there any asymptotes, horizontal and vertical asymptotes? Okay, so all of that was from pre-calc, and now the new stuff from calc. E intervals of increase and decrease, like last time. Any local max and min values, concavity and points of inflection, and then sketch the curve. Okay, so you can find these again on 315 and 316. So let's go ahead and show you the problems and an example of how they work. So page 321. Looks like you can see 1 through 9 there. 11 through 17. And we have to go up to 45, I believe. So I think that covers everything. Okay. Oh, here we go. Okay, number 5, y equals x times x minus 4 cubed. Take two derivatives. First derivative is product root first times derivative of the second, plus second times derivative of the first. A little bit of touch up. Factor out the x minus 4 squared, and you have 3x times x minus 4, or 4x minus 4 times x minus 4 squared. Y double prime, product root again, first times derivative of the second, plus the second times derivative of the first. Touch up, factor out the x minus 4, 2 times 4x minus 4 plus 4 times x minus 4. This gives me 8x minus 8 plus 4x minus 16, or 12x minus 24. So 12 times x minus 4, x minus 2. This is a polynomial, so the domain is all reals. Intercepts, what number makes the value 0? 0 and 4. So 0, 0, and 4, 0. Any symmetry, f of negative x is negative x times negative x minus 4 cubed. That's not the same as the original function. That's not the opposite of the function. So no symmetry, no asymptotes. This is a polynomial, which doesn't have any asymptotes. Okay, so set f prime equal to 0. That's x equals 1 and x equals 4. 4 comma 0, we already got that. 1 is a little bit harder. 1 comma negative 27. Put a 1 here and a 1 here. That's negative 3 cubed, negative 27. Those are my critical points. Do myself a sign chart. So critical numbers are 1 and 4. Here's a derivative. Okay, and I notice whatever I plug in here, except for 4, it'll be positive. So all of these are positive in my sign analysis. Plug in 0, that'll be negative. Plug in 2, positive. Plug in 5, positive. So decreasing, increasing, increasing. So the function is decreasing from negative infinity to 1, increasing from 1 to 4, union 4 to infinity. So I have a minimum at 1 comma negative 27. That'll be a minimum. Second derivative analysis, set f double prime equal to 0. Okay, that gives me 4 and 2. 4, 0, I already got. 2 gives me negative 16. If you plug in 2 here and 2 here, it's 2 times negative 2 cubed, 2 times negative 8, negative 16. Then do my sign analysis here on 2 and 4. So I plug in 0. 12 is always positive, plus, plus, plus. 0 minus 4 is negative. 0 minus 2 is negative. Positive times a negative, positive. Plug in 3. 3 minus 4, negative. 3 minus 2, positive. Positive times a positive, negative. Plug in 5, they're all positive. Okay. We're doing the second derivative. Positive second derivative means concave up. Negative means concave down. So intervals of concavity, f is concave up from -infinity to 2, union 4 to infinity. F is concave down from 2 to 4. There is a change in concavity, so that makes these 2 points inflection points, 2, -16, and 4, 0. So here we go. Decreasing, increasing, increasing. Minimum at 1, -27. Concave up to the inflection point 2, -16. Switch to concave down to 4, 0, and then back to concave up. Okay. And next one I'll show you is 4.529. X minus 3, x at 1/3. You can factor out x at 1/3, x at 2/3 minus 3. Or I can have it like this. I'll need each of these actually at some fashion or another. Okay, intercepts, origin, 0, 0. Domain is all real numbers. You can take the cube root of any real number. Okay, a little bit more on intercepts. 0 equals this. Move this over 3 cube root of x equals x, cube both sides. 27x equals x cubed. 0 equals x cubed minus 27x, factor out an x. X equals 0 or x squared equals 27. So x is plus or minus radical 27, 3 root 3. So my intercepts are 0, 0, and plus or minus 3 radical 3, comma 0. I don't know if you can read that. It says it's about 5.1, I think. Okay, symmetry, f of negative x, put negative x here and here. We get negative x minus 3 cube root of negative x. This is a double negative, that makes that a positive. And this is the opposite of the original. So it's equal to the opposite of f of x. So I do have an odd function. I have origin symmetry. So the final graph is symmetry with respect to the origin. Okay, as far as asymptotes are concerned, there aren't going to be. When x gets big, y gets big. And when x gets negative big, y goes to negative infinity. So no asymptotes. You can probably tell that from here. Yes. Okay, in this fashion, big positive. This is big positive. This is big positive. Big negative. This is big negative. This is big positive. So that takes care of that. Okay, first derivative. Derivative this is 1 minus x to the negative 2/3, 1 minus 1 over x to the 2/3. Double prime, 2/3 x to the negative 5/3, or 2 over 3 x to the 5/3. Okay, x equals 0 is a critical number because the derivative is undefined there. That's at the origin, 0, 0. Then I set y prime equal to 0. Set that equal to 0. 1 equals x to the 2/3. X to the 2/3 equals 1. So x is plus or minus 1. Okay, and 1 gives me negative 2, and negative 1 gives me 2. So negative 1, 2, 1, negative 2. Do a sign chart at negative 1, 0, and 1. So I plug in negative 8. The reason why I pick negative 8 is it's a nice cube root. The cube root of negative 8 is negative 2, square root is 4, 1 minus 1/4 is positive. If I were to plug in negative 1/8, okay, the cube root is negative 1/2, square root is 1/4. 1 minus 4, that's a negative. Positive 1/8 would also give me a negative. Cube root of 1/8 is 1/2. 1/2 squared is 1/4. 1 divided by 1/4 is 4. And 1 minus 4 is negative. And if I plug in a number like 8, 8 to the 2/3 is 4. 1 minus 1/4 is positive. Okay, so increasing, decreasing, decreasing, increasing at these critical numbers. So f is increasing from negative infinity to negative 1, union 1 to infinity. F is decreasing from negative 1 to 0, union 0, 1. That makes negative 1, 2 a max, and 1, negative 2 a min. And at the origin, I don't have either a max or min because it goes from decreasing to decreasing. Okay, y double prime came out to be this. Okay. I cannot set that equal to 0. Okay. But I know 0 would be a critical number because 0 is not allowed. Okay, in this expression, if I plug in a negative, it'll be negative. If I plug in a positive, it'll be positive. Okay, so the function's concave down from negative infinity to 0, concave up from 0 to infinity, so that makes the origin an inflection point. So here we go. Inflection point, vertical tangent, negative 3 radical 3, 0, 3 radical 3, 0, negative 1, 2 max, 1 negative 2 min, symmetry with respect to the origin. Okay, concave down, concave up. Okay. All right, so that is that one. And 4.5, number 9, y equals x over x minus 1. Okay, the domain is all real numbers except for the set consisting of 1. Intercepts is 0, 0. Symmetry, f of negative x is this. That's not the same as the original. That's not the opposite of the original, so no symmetry. Asymptotes, well, you have a vertical asymptote at x equals 1. You also have a horizontal asymptote. Limit as x approaches either positive or negative infinity. You can do Hopital's rule. That'll be 1 over 1 is 1. So y equals 1 is an asymptote. X equals 1 is an asymptote. Y prime. So quotient rule, bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is 1, all over x minus 1 squared, negative 1 over x minus 1 squared. I notice that's less than 0 for all x not equal to 1. So this graph is always decreasing wherever it's defined. So f is decreasing from negative infinity to 1 union 1 to infinity, increasing nowhere, so therefore no max and no min. Okay, for the second derivative, write y prime as negative x minus 1 to the negative 2 power. So double prime is 2 times x minus 1 to the negative third, or 2 over x minus 1 cubed. Okay, this can never equal 0, but I do have x equals 1 as a critical number because that would be undefined there. Okay, so if I pick something less than 1, like 0, this would be negative. If I plug in a number bigger than 1, like 2, this would be positive. So concave down from negative infinity to 1, concave up from 1 to infinity, no inflection points. Okay, there is a change on cavity, but you can't say 1 is inflection point because it's not even a point. It's not in my domain. Okay, so we're all set. Always decreasing, asymptote, asymptote, goes through the origin, first concave down, and then after that, concave up. That's what we have for that one. Okay, 4.5, number 21. X minus 3 times radical x, which is x to the half. Now I can distribute this to the x to the 3 halves minus 3x to the 1 half. Okay, since there's a square root, domain is 0 to infinity. Intercepts, how do I make this 0? 0, 0, and 3, 0. There's no symmetry. You can tell f of negative x can't work because I have a domain of 0 to infinity. And there are no asymptotes. When x goes to infinity, y goes to infinity. Okay, so y prime is 3 halves x to the 1 half minus 3 halves x to the negative 1 half. Double prime is a little bit clumsy. 3/4 x to the negative half plus 3/4 x to the negative 3 halves. Let's clean that up. So this would be 3 over 4 x to the 1 half plus 3 over 4 x to the 3 halves. And this is greater than 0. Okay, so 0 is not allowed. But for any x greater than 0, this expression you can tell, since it's only multiplying and dividing positive quantities, it's going to be positive. So automatically the function's concave up everywhere and concave down nowhere. So automatically there's no inflection point. Okay, try to set y prime equal to 0. So this expression, 3 over 2 radical x minus 3 over 2 radical x in the denominator equals 0. Move that over. 3 over 2 radical x equals 3 over 2 radical x in the denominator. Multiply both sides by 2/3. The 3 halves cancel out. So I have radical x equals 1 over radical x. Multiply both sides by radical x. X equals 1. So I have 1 comma negative 2. Okay, it's a minimum. I already know it's a minimum because the graph is always concave up. So concave up means I have a minimum. So f is decreasing from 0 to 1, increasing from 1 to infinity. 1, negative 2 is a relative minimum. Here's the graph. That's that. Okay, 41, arctangent of e to the x. Okay, you can put any number here and you can take the arctangent of anything. So the domain is all real numbers. Intercepts. Well, what happens when I plug in 0? E to the 0 is 1. Arctangent of 1 is pi over 4. So I have 0, comma, pi over 4. Symmetry. F of negative x is arctan of e to the negative x. That's not the same as the original. That's not the opposite. So none. Okay. Horizontal asymptotes. When x gets big, arctan of a super big number is pi over 2. When x approaches negative infinity, this expression approaches 0, and arctangent of 0 is 0. So I have two horizontal asymptotes, y equals 0 and y equals pi over 2. Okay, so now y prime, 1 over 1 plus e to the x squared times the derivative of the inside, which is e to the x. Okay, side note, I notice this quantity is always positive. That's positive, 1 plus positive, positive. So this function is always going to be increasing. Y prime is e to the x over 1 plus e to 2x. That's greater than 0 for all x. So the function's increasing on all real numbers, decreasing nowhere, and no max or min. Okay, double prime is a little bit more clumsy. So bottom times derivative of the top, minus the top times derivative of the bottom, 2e to 2x, all over 1 plus e to 2x squared. Clean this up, e to the x plus e to the 3x minus 2e to the 3x, or e to the x minus e to the 3x, all over 1 plus e to the 2x quantity squared. Okay, so when is this 0? When the numerator is 0. So I set y double prime equal to 0. E to the x minus e to the 3x equals 0. That means e to the x equals e to the 3x. Divide both sides by e to the x. And I have 1 equals e to the 2x. Take the natural log of both sides. So 2x equals 0, x equals 0. So 0, comma, pi over 4 is a possible inflection point. It is. Okay, so now if I pick something here and here, well, the denominator is always positive. If I plug in -1, e to the -1 minus e to the -3, e to the -1 is larger. So that's concave up. But if I plug in 1, e to the 1 minus e cubed is larger, so that'll be a negative. Okay, so concave up from negative infinity to 0, concave down from 0 to infinity, inflection point at 0, pi over 4. So here we are. Horizontal asymptote, always increasing, first concave up and then concave down the rest of the time. And that takes care of that one. Okay, I do want to go back and do some problems from 4.4. Okay, some of these limits where it was a variable expression raised to a variable expression. So limit x approaches 0 from the right of 4x plus 1 to the cotangent of x. What you do is call this y, that y equal 4x plus 1 to the cotangent of x. Ultimately, we're looking for the limit as x approaches 0 from the right of y. Now I take the natural log of both sides. So ln y is ln of this, that brings the cotangent down. And I can write cotangent as cosine over sine. Now I take the limit as x approaches 0 from the right of ln y. I'll figure out this limit. I'll get the limit as x approaches 0 from the right of ln y. Then I have to exponentiate to find ultimately what I want, which is limit as x approaches 0 from the right of y. Okay, this is 0 over 0 because if I put a 0 here, ln of 1 is 0, sine of 0 is 0. So do L'Hopital's rule. So limit x approaches 0 from the right. Okay, so the derivative of the bottom is cosine. This is a product. So first times the derivative of the second, 1 over 4x plus 1 times 4, plus the second times the derivative of the first is negative sine x. Now if I plug in 0, that's 1 in the bottom. This is 0, so that wipes all of this out. Cosine of 0 is 1. So I'll put a 0 here, that's 4 over 1. So I have 4 times 1 plus 0 over 1, which is 4. So that tells me limit as x approaches 0 from the right of ln y is 4. Then I exponentiate to get finally what I want. So limit as x approaches 0 from the right of y, limit x approaches 0 from the right of 4x plus 1 to the cotangent of x is e to the 4th power. Okay, and something similar happens to 59 of the same section. Limit x approaches 0 of 1 minus 2x raised to the 1 over x. Call this y, which means I'm trying to find limit x approaches 0 of y. So y is this, take the natural log of both sides. When I take the natural log, the 1 over x comes down. In fact, I can write it like this. Multiplying by 1 over x is the same as dividing by x. Now I'll take the limit as x approaches 0 of ln y. That's limit x approaches 0 of ln 1 minus 2x over x. This is 0 over 0. Plug in a 0, ln 1 of 0, and that's 0. So L'Hopital's rule applies. Derivative of the bottom is 1. Derivative of the top is 1 over 1 minus 2x times negative 2. And now when I plug in 0, I get negative 2. So the limit as x approaches 0 of ln y is negative 2. Exponentiate both sides to get what you want. Limit as x approaches 0 of y is e to the negative 2. Okay, so that was section 4.5 and a few more problems from section 4.4.